Math 3, Unit 8, Section 9. So today we are going to be solving these trig equations, but instead of solving them and finding the degrees, which we did previously in the unit, we are going to solve them and find the answer in radians. Having your unit circle will be helpful in your answer, so please have this out as well. And here we go. So on here, just like we did back in the previous lesson, we want to highlight what we're trying to find. So we want to end up finding or getting sine of theta by itself. The first thing you will do is subtract root 2 to both sides. So now I have 2 sine of theta equals negative root 2. And then to get sine by itself, we would divide by 2 to both sides. And so sine of theta equals negative root 2 over 2. And so we want to find what radians, where it is that value. So the first thing that we need to think about, though, is where is sine negative? And so if we're looking at our coordinate plane, sine is dealing with our y values. And so y's are negative in quadrants 3 and 4. Okay? So the answer that I'm going to be looking for is in quadrants 3 and quadrant 4. And so we are looking for the y value of negative root 2 over 2 in quadrants 3 and 4. So in quadrant 3, here are my y values. Here y is negative root 2 over 2. And the radian value at that point is 5 pi over 4. So that would be one of my answers, 5 pi over 4. Okay, we also know quadrant 2 should have a y value of negative root 2 over 2. And if we're looking at our y values, negative root 2 over 2, the radian value is 7 pi over 4. And those are my answers. Okay, so let's go ahead and do this next one. This one looks a little bit more complicated, but you guys can handle it. The first thing that we are going to do is factor out. Notice here that both of these have 3 sine theta. And so that's going to be my GCF, 3 sine theta. So if I take out a 3 sine theta, that means I'm dividing this by 3 sine theta, which means these cancel out, and I'm just left with tangent of theta. And if I divide this by 3 sine of theta, these cancel. And when they cancel, I'm just left with 1. So all we did was take out a GCF. Okay, and then now we have these two factors, and we're just going to set both of them equal to 0 and solve. So here I have 3 sine theta equals 0. I want to solve to get sine of theta by itself. And in order to do that, I would divide by 3 to both sides. And I end up with sine of theta equals 0. Okay, so we know that sine is dealing with the y values. So because this is 0, whenever we get zeros or ones, we know that it's going to be like on our quadrantals, like at 0 and that. So where is y 0? And we kind of dealt with this a lot when we were making our graphs. But y is 0 at 0 and 2 pi, because that's 2 values there, because we're going all the, oh, it says less than 2 pi, so we're just going to do 0. If you wrote 2 pi, I wouldn't mark it wrong though, so just at 0. And then y is also 0 at pi. Okay, so those are my answers for this part, but we're going to have another part here for tangent. So now I have tangent of theta plus 1 equals 0. We subtract 1 to both sides, and I have tangent of theta equals negative 1. Now, tangent's a little different than sine and cosine because tangent is y over x. Also, we have tangent is negative 1, so we need to figure out where is tangent negative. And so if we're looking at our coordinate plane, okay, remember in quadrant 1, because we're going, this is our y-axis and our x-axis. Going to the right we know is positive, left is negative, up is positive, down is negative. In this quadrant, y and x are both positive, so tangent's going to be positive. In this quadrant, our y is positive and our x is negative. So positive divided by a negative makes a negative. In this quadrant, our x is negative and our y is negative. So a negative over a negative makes a positive. And then this left right in here, we have a positive divided by a negative, and we end up with a negative. So tangent is negative in quadrants 2 and 4. So we are going to get a negative 1 value in quadrant 2 and quadrant 4. Now remember with tangent, and right now we're looking at quadrant 2, if I were to put y over x, I'd have root 3 over 1. On this one, root 2 over root 2 would reduce to make 1. Here, 1 over negative root 3, it's not going to give you 1. And so this is what's going to reduce to be negative 1. And so the radian at that point right there is 3 pi over 4. Okay, going down to quadrant 4 now. Which radian value will give us a negative 1? So again, the root 2 over negative root 2 would reduce to be negative 1, and so my radian value right there is 7 pi over 4. So these 4 answers are the answers to this equation. Okay, so we'll go ahead and we're just going to do, I think, 2 more, or I don't know, we might do all 3. Okay, so these are already factored for you, so we're just going to split them up and set each of our factors equal to 0. We have root 2 sine of theta minus 1 equals 0, and cosine theta plus 1 equals 0. And then we're going to go ahead and solve. So here I would add 1 to both sides. We are trying to get sine of theta by itself. I have root 2 sine of theta equals 1. In order to get sine of theta by itself now, I would divide by root 2 to both sides. We need to rationalize the denominator, and so I would multiply by root 2 to both the top and the bottom. 2 root 2's end up making a 2, so I have sine of theta equals 2, and then 1 times root 2 is root 2. So where is sine positive? Well, sine is positive. Our y values are positive in quadrants 1 and 2. Because y goes up, up is positive, so quadrants 1 and 2 are where we'd find our answers. So looking at quadrant 1, I'm looking for a positive root 2 over 2 for our y value, because sine is y. So looking at our y values, positive root 2 over 2 here in quadrant 1, in terms of radians, that's at pi over 4, or 1 pi over 4. Okay, in quadrant 2, we again are looking for root 2 over 2 for y. And so looking here in quadrant 2, y is root 2 over 2 right here, which is 3 pi over 4. So those are our answers for that side. And then we need to figure out cosine of theta plus 1 equals 0. We are trying to get cosine of theta by itself, so I would do that by subtracting 1 to both sides. Cosine of theta equals -1. And so we are looking for where is x -1. And so cosine, when we're dealing with like negative ones and positive ones with sine and cosine or 0, those are going to be at our quadrantals. And so where is x -1? So if you look on there, the only place where x is -1 is at the 180 mark, and in terms of radians, that's at pi. Okay, and so this answer for this one is pi. So for this problem, it's all three of them. So pi over 4, 3 pi over 4, and pi. And those would be our answers. Okay, let's go ahead and look at this problem down here. Again, we're trying to solve for cosine of theta. You'll notice on this one it says cosine squared of theta. So we're going to have to think about that here in a minute. But before we have to worry about that, let's just try to get it by itself. We'll start by adding 3 to both sides. That eliminates. 4 cosine squared of theta equals 3. In order to get cosine squared of theta by itself, the next thing I do is divide by 4 to both sides. These eliminate. We have cosine squared of theta equals 3 over 4. Now, how would I get rid of a square? How do I get cosine, just cosine instead of cosine squared? So hopefully you said to take the square root. So we're going to take the square root of everything. When we do that, we end up getting a positive and negative number because we know that these would become absolute values, and inside the absolute value you can have a positive answer or a negative answer. And so I'm going to put cosine of theta equals plus or minus. On the top we have root 3 still, and in the denominator the square root of 4 is 2. Now, because it's saying cosine can be positive or negative, we're going to end up having 4 different answers, because in every single quadrant cosine is positive or negative. So we're going to get 4 answers, all 4 quadrants, and so we're looking for where is our x value, either positive root 3 over 2 or negative root 3 over 2. So let's start at quadrant 1. Okay. So let's just put it right here. In quadrant 1, we're looking for root 3 over 2. So x is root 3 over 2, right here. So I want it in radians, so root 3 over 2 is pi over 6. So one answer is going to be pi over 6. Okay, in quadrant 2, we are looking for, again, root 3 over 2. Where is x root 3 over 2? So in quadrant 2, x is root 3 over 2 right here, which is at 5 pi over 6. And remember, it could be positive or negative. So here it's negative. Our radians is 5 pi over 6. So now we're going to quadrant 3. Again, we're looking for x can be positive or negative root 3 over 2. So here is our quadrant 3. Looking at our x values, here's a negative root 3 over 2, which is at 7 pi over 6 radians. Okay, and the last one, quadrant 4. Again, x being root 3 over 2, it could be positive or negative. And right here, this is where x is positive root 3 over 2, which in terms of radians is 11 pi over 6. Okay, and that's it. You would do this other example the same way, where you'd have to just set it up as 2 equations, but I don't think that you guys need that extra time.